Agora a gente vai para a nossa terceira e última apresentação. Essa apresentação ela vai acontecer 100% em inglês, né? Então, a partir desse momento, nós estaremos mudando o idioma do evento para o inglês. Bom, não faço a mínima ideia como que eu vou fazer isso formalmente, mas vamos lá. From now on, I will be speaking English only, and yeah, I would like to introduce you, my friend. Where is it? It's Antranig. So Antranig, he's a Elixir Erlang developer. I met him in the FreeBSD community. We've been talking about Elixir and Erlang and Otp and all that stuff for some time, and I invited him to come and share some of a bit of his own knowledge with us. So today he will be talking about. Let me double check. The presentation is entitled "The Otp Ecosystem in a Nutshell." He'll be presenting all the Otp functionalities and all the greatness that you can use and leverage from such a virtual machine. So, Anthony, are you around?
Oh, hi there.
Hey, how's it going? Are you able to? Sorry, my English is kind of horrible. So, were you able to understand anything that we were saying? Can you hear me?
I could figure out some words, obviously, like for example, varios. Yeah. Can you hear me?
Yeah, I do. I think there is some lagging between us.
Okay. Well, I mean, we are at the other ends of the world, so.
Yeah.
I could figure out some words, like varios nodes. Various nodes, for example. That's easy. So and apparently I also know HTML, so that's also a common word in all languages. So daily stuff, whatever you hear. Apparently, cool. Good talk, guys. I really enjoyed both of the talks, especially the live dashboard. That was very nice, very detailed, actually. Okay, so before I start, I have some questions. Can everyone check their reactions button? There's like two reactions, a clap and a thumbs up, I think. Like if I do a thumbs up, I think you will see like a thumbs up. Exactly. Okay, perfect. Okay, and then, but I have no idea when it leaves though. Let's see if I do a thumbs up again. Okay, so it takes, okay, it has like some kind of a timeout. Okay, perfect. Let's do it this way. Let's do like a small statistics. We have around 31 people. Okay, without me, it's going to be around 30 people. Whoever wrote an Elixir code before, do a thumbs up. Like if you ever wrote any Elixir code before, do a thumbs up. 1, 2, 3, 4. Let's see the other end. Okay, 5, 6. Okay, so the list goes on. And +1, +1, +1. Okay, perfect. Okay, okay, so some basic stuff to see how you guys are at that part. Who here, or you can write on the chat if that's okay. Who here has ever done mobile programming? Some Androids, iOSs. I've done some Symbian in my old days. I don't know if people remember that, actually, some stupid Java stuff. Okay. Okay, great. Okay, we have some mobile devs. Okay, how many of you here have ever done operations, DevOps stuff like Cordova? Oh my God, DevOps stuff like yeah. Okay, perfect. Okay, so we have some people here. Okay, and who here has done old school computing, like system administration? When you couldn't do AWS buy my server, you actually had to buy a server, put it in your house, put a cable, buy a static IP from your ISP. Thank God, no. Yes, yeah, well, yep, we're setting up HA proxies. Yeah, well, old days were, okay, perfect. I was wondering if anyone has ever done any larger scale deployments on production, any language, whatever it is. Say if you had more than 1 million users. 1, 2, okay. 3, okay, nice. 1, 2, 3, 4. Okay, great. So we have some people who have done larger scale deployments. That's very good. A few 100,000, I think. Okay, that's also very good. That's also very good. Okay. Can I ask on which platforms, like systems or operating systems or programming languages, or whether it's mobile or people have been using something called the Firebase these days? Okay, PHP Drupal, that's very impressive. Ruby on Rails, that's very sad. So Rails, Ruby. Okay, so Ruby is the most common case, I think. Okay, amazing. Okay. Okay, and let's see. Linux.js, Postgres, Postgres, amazing stuff. And any of you here have ever done low-level programming like C, C++, or assembly or anything similar? COBOL, you know. No, please don't do COBOL. That would be very awkward. STM32, okay. Okay, perfect. C, C++, that's amazing. Yeah, university assembly, okay. That's, you know, assembly hasn't changed very much, so okay. Okay, perfect then, okay. Let's see if I have any other questions in my mind. Okay, I think that would be, oh, and of course the most common, who here uses Windows, Mac OS, Linux, BSDs, you know, the typical operating system warfare. I see most of you use, I assume, what's it called? The editor these days, VS Code, right? Yeah, okay. Mac OS, Mac. Okay, mostly are coming Linux and Mac. Okay. Okay, nice. Okay, so we have a mix of everything. Okay, perfect. Sublime. Okay. Oh, NeoVim users. Okay, nice. Emacs. So yeah, don't use Emacs. You will hurt your hand. I did it once. I needed to go to the hospital. That's actually a true story. Flame wars. No, don't do flame wars. Okay. Okay, perfect then. Joel, can I share my screen? I don't know if I can. Okay, turns out I think I can. Let me just put up some small presentation that I had in my mind. I also put up here the view of that. And let me try to, where's the chat? Because I want to keep the chat open. Wait, participants. No, I don't think it's that. I actually have no idea on, okay, here we go, chat. Okay, I really want to keep the chat open. Perfect. Okay, so OTP ecosystem in a nutshell. If you have any audio problems or anything similar, just let me know. If you don't understand the word, let me know. If you have a question, but you think it can be like a later on question, can I do X with Y on Erlang? Keep it for the later. If you have a question for like now, I didn't understand how X got here, you may ask at the same time. Just put up your audio or your text and let me know. And yeah, that's it. Okay, so I'll get started. It's not a very long talk. It's not even a talk, actually. I didn't even do a presentation. It's just like 3 slides. Hello, who am I, and the bye-bye. So because, you know, running a company is complicated. I didn't have the time much, but I prepared some demos so we can work on it all together and see how all of that goes. The topic is the OTP ecosystem in a nutshell. Basically, how the Open Telecom platform gives you like a solid ground to develop your applications, and specifically larger scale applications. So my name is Antranig Vartanian. Antranig V is my nickname. I am the CEO of Elug Security. Yes, I still do code. People keep asking me that. I code every day. I am also the head of EVN CERT, which is Yerevan-based. Yerevan is the capital of Armenia. Armenia's national computer emergency response team. Whenever some big hack things happen, I get a call 4 a.m. which says, you know, something in Armenia got hacked. Guys, try to fix something. pretty much that's how my day goes. I'm a Unix guy. I use Unix daily, obviously. I use BSD more specifically. I use FreeBSD. By day, I'm an Elixir developer. I don't do web, by the way. I just a week ago I started learning Vue.js, which is, you know, it's good, but I don't know any web. I only know low-level programming and scaling. So I'm an Elixir dev by day, and I do FreeBSD hacking by night, mostly working on their container subsystem. It's called the Jails. And I don't always do microservices, but when I do, I make sure I use Erlang. That's the right way to do it. That has been always the right way to do it. A small disclaimer: I have no idea what the hell I'm talking about. So, you know, just keep that in mind. Elixir and Erlang wise, so I've been using Erlang systems since 2013, almost 7-8 years now. Mostly running Jabber servers. It's called XMPP protocol. The most biggest Jabber server there is called eJabber written in Erlang, and also WhatsApp uses that. If you've ever used WhatsApp, then you've probably used XMPP. If you've used XMPP, you've used Erlang with Jabber. They go really very, very good. I started maintaining XMPP servers for other companies. That's how I got into Erlang, and I've been using Elixir since version 1, I think. Since version 1 or 1.1. Back then, they didn't even have the send command. The send was an Erlang-based bang. So like it was really, really, really old. But I didn't get into it. I thought it's a very non-mature language. I am one of those people who thinks that Erlang is a beautiful language. It's very sane to use. Most people who come from Python and Ruby are like, no, what the hell is wrong with you? I'm like, I don't know, maybe everything. So let's not open that door for today. So yeah. So then Elixir got very modern, and it was very usable about 1.2, and I had a couple of companies. I was their CTO, and when I gathered the teams, I said, okay, fine, let's use Elixir. And then you have to like unbrainwash people who've been doing object-oriented programming for 5 years and teach them how to do concurrent programming. So that's how the whole idea got in, basically. So this is our agenda for today. Our agenda are going to be processes, naming stuff in OTP, gen servers, a basic concept, how to have a supervisors with a supervision tree, nodes, how to have a multi-tenancy, global processes naming, process loop, and basic intro into key value storages and databases in Erlang, and of course a Q&A. So that's going to be on that part. Let's see. Okay, I think I should share my whole screen now because I have multiple terminals running and I really don't know how to use. Okay, this is my stuff apparently. Okay, Joel, is my screen visible? And how can I put, okay, dock to top,
yes,
I think.
It's visible, it's okay.
Okay.
What exactly are you trying to do?
I'm trying to, okay, this is, I really don't know how to use this GUI, man. I really haven't. Okay, never mind. Okay, sure. Okay, let's go back to the basic, the fundamental concepts of processes, right? So in Erlang, in Elixir, we all know that we have this concept that are called processes. What do processes have, right? Since it's based on the actor model, processes basically have, our actors have 4 properties, which we always think about them. The first one is that they have an identifier. In this case, it's a PID, or we can type in self and see our own PID. They do a compute. They have a function. They do some kind of computation. They have some kind of a state that they are in. And in the end, they have some kind of a mailbox. They have a mailbox in which they can, fetch in stuff and, send messages back to other people. So I wrote a small module here. Let me try to do it, I think this is good, maybe, and a terminal around here. Okay, so I made it as short as possible. We have our zoo module, right? We have a zoo, right? And we have a dog, and our dog is doing stuff. He's barking. And we have a cat, and our cat is meowing, as always. And so that's what dogs and cats do. And now let's create a process in the background that goes and does things, right? So maybe I can have a dog in the background. So I'm going to need to spawn a new process, right? So that's the first thing that we can do. We can spawn a process. So this is where the basic idea of microservices start to come in. Now you can have here picoservices, nanoservices running all around. You can have multiple millions of these running, all in the Erlang VM. So this is the basic concept that we can start with. Okay, so great. If I spawn my, zoo.dog, which is going to be very nice, I can do end. Okay, I have a function that I'm running, and it did run, and it also had a PID. Its PID was 154, but I cannot see now bark, because bark was, the return value of the function. But now the function is somewhere. So, I don't see the return value. But however, I do have a big dog which barks very loudly, and I can see it because I've used IO puts in this case. And for example, I can do a spawn a new function which will be a zoo.big dog. And now I have my big dog. Although the big dog is screaming somewhere, I can still hear its woof woof coming to here. And that's now I have my big dog just woofing around, which is very good. But now, okay, so now we got the very basic concept. So I'm able to spawn processes using spawn, obviously. So let's try something else. Let's try having a group of dogs playing around all together. Right, so I wrote a small function for that, and we have a playing pack, which is a group of dogs, and what's going to happen? They're going to waff all around. They're going to wait for a couple of seconds, and then they're going to start playing again, because that's what big dogs do. They just play all day long. So great, let's start doing that. So I'm going to spawn a new process, and let's name it. Okay, here, great, zoo.playing pack. Now we have our playing pack end. Right? So now, waff, waff, great, 2.5 seconds again, and they're screaming all around, and it's 4 a.m. here, and I can't sleep. So the next thing that I need to do is to kill a process. So this is the part where the Erlang runtime comes in, right? So these processes are all separate. They have their own heap and stack. When you need to do some kind of a garbage collection, for example, this is not the Java style stop the world garbage collection. Everything is on its own. So killing this specific process will not affect any of the other processes. So in here, we also have something called process.exit, for example. I can give it the PID that I want to exit. In this case, it's a 0, 158, 0, great. And I can say to it, how do I want to exit it? I want to kill it, basically. Poor group of dogs, they're gonna die. And now they're dead. So it's not running anymore. A very basic way to handle processes inside Elixir, inside the whole Erlang VM. Okay, so now we had two parts, right? The first part is we can have a process running somewhere. And the second part is we can also talk with these processes using the runtime, for example, killing the process. So those are the very basic things that we do. Now the process, by the way, it also has very important things in it. If I do like process info and do a self, so I can see what's happening inside my own process, I can get some basic info, like what am I running? What were the last messages that I got? What is my own PID? Do I have an exit trap if something, dies? How many functions have I called until now? How many function calls have I? Those are called, for example, reduction counts, right? My heap size, my stack size, etc., etc. In live view, what we were seeing was basically fetching all of those ideas and putting them on the live dashboard. So this is what it was doing. So any process can ask anything about any other processes, and they can all talk together and get information about each other. And this all comes within the Erlang system. I don't need any third party to manage any of those, which starts to give us a very basic idea of how good Erlang is built. My self process is basically called EIX evaluator, which is the eval function, which takes in Elixir code, does an eval loop, and prints it back. So this is my own process that I'm running. So now let's get to the next part, which was message passing, right? We have mailboxes, great. Here we can have a kitten, a waiting kitten, which will wait for a message to play with, and then it will print that message, right? It will say meow, whatever it is, and then it will exit. But if we don't play with it for a couple of seconds, it will start, bugging you, telling you, please pet me, and please pet me. because that's what cats do. And then it's gonna go back to just waiting for you guys. So, okay, maybe we can run our kitten. So now we have our own kitten. Let's have our own kitten and spawn it. We can spawn our kitten, which is a function, which is zoo dot, what was the function name? Waiting kitten. Great. So, and here we go, right? I saved the value of the PID inside the kitten variable just in case. And now the kitten will wait for 7 seconds, then it will get bored, and then it will come and ping me and say, please pet me. And then again, please pet me, until I send it the message. When I send it a message, it will receive that message and then it will exit. Great, so maybe I can do that. I can say send, I can send a message to our kitten, telling it, for example, Joel, let's say, and then I can say enter. And now we got, meow Joel. That's what the cat said, meow Joel, and then it exited gracefully. So until here, we got the whole concept of, sending a message, getting something back. So this is how our lovely kitten has been talking to us, right? I send it a message, it receives it, fetches it from its mailbox, does something with it, and then it's done. A very basic concept of nano services, pico services, and the list goes on. Okay, so those are the very basic concept with processes. Now, if you grasp those, the rest are just fundamentals of the following, right? So let's see. Do we have any questions until here? I have no idea. I can chat. Great, perfect. Great, no questions. Very nice. Okay, let's continue from here then. So now, if we want to make an actual complex system where you have to send messages and receive them back all the time, you cannot sit and write every send and why does it return? That's a very good question, Yuri. So why did it return the Joel string back? Now, the Joel string that we see in here, it has nothing to do with the kitten. It has to do with the send function. The send function prints on your, well, it doesn't print, it actually returns to you what you wanted to send to the other process. So if I send, for example, to myself, right? If I send to myself the PID of myself, it will print my own PID. And then if I flush my mailbox using the flush command, it will also print my own PID because I sent my own PID to myself, obviously. Or you can send it somewhere that it doesn't even exist, because in Erlang, those are the bad parts, which we will discuss it later on, and see, what have I done? Like, I can send it to the PID named 0 dot something something, right, dot 0, and you can also send that. Well, that's not true because I wrote it very, very, very wrong. It cannot exist in that size. Let's see, let's do it 1, 2, 3, for example, and send, it send it, but it probably exists or doesn't exist. We don't know if process 1, 2, 3 exists or not. So those are some problems with Erlang, which will go into it. Yes, so it will just show me what I've tried to send, if I am, of course, in an interactive shell. So there goes that. Okay, so if we don't have any questions, or if we have any questions, go on. And if we don't, we just grasp those main 4 ideas and we start building our whole concept of concurrency on top of that. Okay, great. Go on.
Yeah, no, I have a quick question. I see that you're using the send. From what I understand from sends, that you send a piece of information to another node, so this node receives it, or actually it's for another process, and I'm assuming this process might exist on the current node or on a different node in the cluster.
Exactly. We will get to that on the basis of creating those foundation. But the idea is that the process has no idea where it exists. That's the main idea. The Erlang runtime system is built in a way that the process has no idea whether I am on this node or whether I am on the other node. When we get to that place, I will show you specifically how it is done underneath. Because as a process, you have no idea where you are even receiving the message from.
Yeah. What happens when I send the information? It's the same question for 2 scenarios. What happens when I send the information to this process? So this process receives this information, process, and then it exists, it exit, or it keeps running and waiting for older, if I say, older messages.
Great question. So if I send multiple messages, okay, so the processor's job is whenever it is supposed to read the message, it will try to get a message. Now, this is where the pattern matching part of Elixir and Erlang comes in. If I have a generic pattern matching, which is in this case foo, it will just look for any message. If I have a specific pattern matching in there, for example, I am looking for something that starts with a tuple 0 and something, it will look specifically for that and fetch that message. But what underneath is happening, there are multiple scenarios. It could either be copying the information of the message, or it could be referencing to it, to the memory of that. The copying is done always when it's happening on multiple nodes, but on a single node, it either if it's a big chunk of information, let's say you are sending a huge CSV file, for an example, it could just reference to it. And if it's a small kind of information, it would just say, copy the information, put it in the memory of the other process. And then, the process goes on. Now, regarding the killing or the continuation, that's your own business logic. If in my case, I wanted the cat to die, right? I wanted the cat to say meow, and then I wanted it to die. But if I said, you know what, don't die, stay there as you are, and just continue doing your loop. Now, again, this is also one of the fun parts of Elixir. I can just say rzoo, and it will dynamically load my code without even shutting it down. Now my code has been compiled again, and I can run my kitten code again. Okay, now I have my new kitten, right? 175. And it will wait for some time, and then it will tell me, please pet me. Great.
So now you have process running.
I have one because the old one died. The old one's job was,
okay.
It said meow Joel and then that. But now if I send it again a message and say, okay, let's say kitten Joel, it will say meow Joel. But then it will also begin the loop from ground because it got the message, it did its job, it exited the receive loop, and now it's back to waiting kitten. So now I went back to itself.
Oh.
So you can do whatever you want.
You created a manual loop. Oh,
yes.
So when you have this, so if you end up executing all the instructions and you don't call the function back again, it will die.
It does.
Okay,
it does.
now it makes sense.
But okay. Theoretically speaking, what I created here, it's a cat server. It's a kitten server, right? I tell her something, it returns back meow, that name, right? Now I created a very basic client server concept. Are these Erlang processes green threads? A good question, Yuri. Yes, those are green threads. On the operating system level, what's happening, whenever you're creating Erlang process, which in this case, is my EIX, right? Sorry, IEX. I keep saying EIX, that's a gentle thing. My IEX. So my IEX is actually one process on the operating system. But what it does, it creates one thread per scheduler per core, per thread of your CPU cores. For example, if I have on my machine eight cores or 8 threads, it will create 8 separate operating system threads that will act inside the Erlang VM as a scheduler. So now whenever I have like those millions of processes running around, it will just take those jobs and give it to the schedulers. Right? It's like many tasks. It will take it, give it there. So it is green threads. The operating system has no idea of what's happening inside the Erlang VM. Like it has absolutely, actually we can even check that if we want to. Like if we run the terminal here and say top, well, top would be very bad. I hate macOS stop PSAUX. We can see, we have lots of processes, and then I can do grep beam, for example. And here I can see that I have my beam process, right? I have my beam process, which is running, and my beam process is just one process. So each scheduler for one operating system thread, yes. So if I have no idea how to see my threads actually on macOS. I'm more like a BSD guy, but I'm going to assume if anyone knows, it's a very good time to tell, by the way. How to see the threads of the thread? How to see the thread.
You will execute the process monitor, I think. Yeah, actually, the process monitor is about processes. Yeah, I don't.
Oh, I got your point. Yes, activity monitor. Here you go. Right. So, and here, if I go and do a view of all processes, can I see also the threads? Well, this is the part where I start hating macOS. So, let's do it hierarchically. Let's see if we can see it that way. And if it does show, we will be able to see the threads of Beam, which I should bring it like here. Beam, right? No, I can only see one, but maybe not really. No, unfortunately, not really. Okay, PS minus T, thank you. Oh, so it's same as BSD. PS minus T minus P, and our process in this case would be this. And now I can see the thread. Great, now I can see the threads. I think now I can see the threads. AUX minus T. And let's try to do it. Oh, so this is where you start hating desktops. Oh, for example, here we have the Earl child setup. This is one of the threads for the system. And let's try doing it this way. Grep Earl, right? And okay, here I can see one process that it should act as having threads. Actually, let me try to show you that on my FreeBSD machine later on to see what's happening on that level. So yes, it will be each operating system thread for each thread that your CPU has. And actually, if you also run it here, Erlang does find that automatically. Okay, I have an SMP, symmetric multiprocessing, 8x8. So, right, it matches 8 cores with 8 Erlang schedulers. So then it continues to work. Okay, now we have our own basic, kitten server. Okay, any questions until here? Okay, great. Okay, so now making this is going to be complex. Making a server with every time making a receive, then handling all of this, all of that. It would be very complicated on the long run. So what we have in Erlang is this concept called behaviors. Behaviors are basically a group of predefined callbacks that we can use whenever we want to do any X kind of thing, right? So a very good example would be if we want to have some kind of a generic server, a server that gets messages, replies back. A server, when it gets messages, does a side job. A server, when it gets messages, changes its own state, because we define that everything has a state. So for that case, we can go from our simple zoo to our super zoo, where I have my super zoo. And this is a very basic implementation of the gen server. So let's go here about line by line. So whenever I type in use gen server, now those whole callback implementations are imported into my module. And now whenever I try running this module with using only use gen server, it will say, oh, but please have a function named init, because gen server requires having init. So then we go. Now gen server has very basic commands. One of them is init, which takes an argument, and then it should always return a tuple of OK if it runs properly, and a state, any type of state. In this case, I wanted my state to be an empty list, right? You could make it anything. So an empty list is the smallest value that we have, so I just put it there. You could execute observer start on IEX and watch the Beam processes in the GUI. Yes, that's true. That would be very fun. The observer start. And here, this is also part of the Erlang system, right? I can see my system, I can see my system version, my compiled for, how many total memory usage, etc. So those are all part of the system itself. Well, which is basically just a graphical interface for process.info underneath. Okay, great. So and now I have a init function, right? Now the init is going to do some kind of a job. And it's going to initialize, then it's going to always return a tuple of an OK and my new state. Now I want to play with this state, right? I want to send messages. I want to receive something back. So let's say we have a zoo, and this zoo is going to say have some kind of a let's play function, right? Let's play, and whenever we play, we save what we did today in our state. We add that play into our state. Right, we append that to our list of states. But what we can see here, that cast has an answer of a tuple, which should always be a tuple, which the first of all is no reply, which means we're not replying anything because it's a cast. right? I'm just casting some stuff. And then the second part of the tuple is going to be my new state. So what's my new state? Is my old state plus my new type of play. So as we said in the presentation, what we are going to focus on, one of them is naming stuff, right? How do I name stuff? So one of the main ways to name stuff that in Elixir and the Erlang VM, we have an internal naming system, something that each VM has inside of it. And to use that naming system, you can do is a process.register, and I can register a name. Let's say I want to register myself, my own process, as foo, right? And it's true. Okay, I just registered myself as foo. So whenever I do process.whereis, who is who, where is who, where is foo, I can see that I am, which process is that. So this is a very basic naming mechanism. Instead of saving it in a variable and passing this variable around, I always know that my web server's name, for example, is going to be web server. So I just do a process whereis, and I get the process ID of that process. Now, this is the basic part of that. Now, to use this inside the gen server, which means whenever I want to implement, whenever I want to run a server, and I want to give it a name, right? We have our own gen server start link function. And what I say here, please start my own module, right? This is a macro, which means start my own module and give it an argument of an empty list, right? I don't want to give it anything. I just want to give it an empty list and name it by the name pet, right? It's a variable. Whatever name I give to it, it will register it that way. So now we can try that action. Now we can go here and wait. I hope you guys can see or can't see. Can you guys see my terminal? Wait, let's do it here. Okay, perfect. And I don't need nerd 3. Perfect. So here, for example, in my super zoo, what I can do is I can start my new machine. Hopefully I didn't change any code. Oh, great, now it started. And now I can call this, right? I can now call the super zoo dot, let's say, what's it called? Start link, great. And for the super zoo dot, I did name it something, apparently. Okay, superzoo.petland, great, and now I have my start link function. And now for my start link function, I want to give my pet a name. Let's name it Lua, right? Lua the cat. I actually had a cat named Lua years ago. So now I have Lua the cat. And now Lua is running. It returned to me, the gen server process. The gen server initiation process returned to me in OK, and the process ID of that process. Now I can either talk with this process by that process ID, or I can use its name. So if I do a process dot where is who Lua, right? I can get that PI. So now it's registered internally into my system. This is a very basic naming mechanism that we can use. Okay, questions until here? No, none? Okay, great. Let's continue on. Okay, so let's say now I want to do some kind of server stuff, right? So we defined that the messages that we want to receive, one of them is cast, right? Handle cast. I implement handle cast, which is called let's play. It gets an argument of a tuple of let's, the atom, and play, which is a variable, and adds that there. Now, what I want to do is, this is my server calls. What I can have also is my client calls, a basic wrapper library to use it with my server. So I did that in the same module. So to make it more basic, here we have the init API, right? Here I have the init API, and here I have my server API, and down here I start creating my client API, right? So I have a function which is called let's, which takes two things, right? It takes the name of the pet and the function that I want to play with the pet. So what it does is it sends a gen server cast, which also takes two arguments, two or more, which is the pet, right? In this case, the name of the gen server could be the PID, or it could be the registered name internally. And then it will call the let's play. So instead of me using every time gen server cast, gen server cast, gen server cast, or you might want to do some kind of a computation or a formula before sending those messages, you can do it all in your client API, and then you can send the message. Okay, so now I want to play with my Lua cat. So what I can do is, what was it called? Superzoo.petland. let's play, right? Let's play with who? Let's play with Lua, and let's do what? Let's play, for example, get some food, right? Okay, great. So this is my function call, and okay, and the message has been sent. Now I don't have to write senders and receives and handle them every time anymore, right? Now the gen server behavior does that for me. It's all implemented inside the callbacks, right? You only declaratively imply on what you want to have, and the gen server will handle that for you. So if now I have a call, for example, which is called what's up, right? And the what's up says it will reply back to me. What's it going to reply back to me? It's going to reply back to me the state, right? It's going to reply back to me the state, and it's going to set the new state as the old state, right? We have the reply, and then we have what are we going to reply, and then what we have is the new state. Of course, in this case, my new state is the same as my old states, which means I haven't changed my state. So we can also do that, right? We can do like super zoo.petland.whatsup, right? What's up who? What's up Lua? And I can get some food. Then Lua decided that it wants to play some games, right? And it says play with Joel, right? Now it wants to play with Joel. Okay, great. It went and played with Joel. Then we can ask it again, what's up, Lua? And it says, I got some food, and then I played with Joel, right? And the cat doing cat things, basically. So because what happened, we just appended to our list, and then the cat is going to go to sleep, right? And now I also have here my sleep call, and in case of a sleep, it's going to return to me what the cat did the whole day. Where is it? Yeah, it's going to return to me what the cat did the whole day, and then it's going to clean the state, bringing it back to a fresh state, an empty list. So then we can say super zoo.petland.sleep, right? Who Lua, obviously, and then Lua says, this is what I did all day. And now if we ask it what's up, it's an empty list. Right? This is a very basic implementation of the gen server. From here, you can scale out to very, very multiple things. Questions until here, if any?
Yeah, I do have one. I just want to make sure that I understand it correctly. I can see you have a handle cast and a handle call distinguished functions. So I'm just wondering if the handle cast is supposed to receive read-only carries or messages, or if it's not related to the responsibility.
Oh,
I mean, I'm just wondering why you have cast and call distinguished.
Right. So cast and call have two differences. First of all, in case of a cast, you have no idea where you don't know, and also you don't care where the call is coming from. That's why in handle call, the default amount of arguments are 3, right? My pattern matching argument, my from argument, which I don't use, right? And my state. But in case of a cast, I don't have a from. It's only the arguments and the state, right? So that's the first difference. The second difference is, in case of a cast, you don't want to receive anything back. Like a very good example of this would be a shopping list, right? If you want to add the stuff in your shopping list, you would use a cast. I'm just adding this stuff. But then when you want to read your shopping list, I'm going to use a call. So I get a message back, which says what I have in my list. So that would be a very basic difference. The other difference would be that cast, because it doesn't require to know who is it coming from, and also it doesn't require, for example, how to send the message back, it's also more lightweight. So if you actually do not care of sending a message back, don't send the message back and use cast. It will be more lightweight than using a call. Call will be more complex, obviously, because of how the way it's implemented. So that's the main difference. It's a basic design idea. It's a basic design implementation differences based on the generic needs of a server, right? Because sometimes you do want something. If you have a web server, right? Sometimes you just want to do a put request where you don't care about the output back, and sometimes you want to do a get request where you actually want to get some stuff back. So that's the main difference. And that's also the main difference, like when you do a post request and the put request. In case of a post request, you always want to see something back. In case of a put request, you do not want to see anything back. It's the same idea with a cast and a call. basically. William France has a question. If I'm not wrong, basically cast is async and call is sync. Yes, that is also correct. In case cast is async, that being said, I do my genserver.cast thingy and just move on. I don't wait for any reply. In case of a call, I will wait for a reply. And the default timeout, by the way, that's very critical because I lost like 3 days back then when I didn't know that. The default timeout is 10 seconds. If you have a process that is taking longer than 10 seconds, either you should longen your timeouts, or you should find a way to do that asynchronously if you need to. So those are also very basic differences. Yes, the cast is async and call is sync. Thank you, William. Joel, does that answer your question?
Yeah, it does.
Okay, great. Any other questions until here?
I have a little basic question. The brackets that means the optional let me see, optional subject in this function. For example, handle cast. We have a bracket, let's and play. I want to know if this optional.
Oh, you want to understand what lets and play? Okay, great. So you might need multiple type of casts and you might need multiple type of calls. So what we do is we do pattern matching, because Erlang and Elixir also can do pattern matching down to the function calls. The function definitions. So that's how we use it here. Because we can do can do pattern matching down to the function definition. That's what we use here.
Okay. It's the same in another function languages.
Yes.
The same in other languages. Okay. Thanks.
Yes. Okay. Let's see. A very good example, by the way, would be doing this def play, right? Play, which if it says if it takes an argument as a dog, right? Do let's say, wait, I don't want to mess up this module. Let's mess up the other module. That one doesn't have much interesting things anyway. Processes, lib process. Here's my process. This is very large, and here, right here, what I can have is I can have a dog with no argument. I can have def dog with one argument, and let's name that argument 1, right? Do, and it will say bark, and I can also have def dog sorry, with 2 arguments, which will say bark, right? So now if I come here and recompile that module, which was called zoo, and I can do zoo.dog, it will be the first one. If I do zoo.dog1, it will be the bark one. If I do zoo.dog2, it will do, the third one. So although you have the functions with the same names, Elixir can do the pattern matching up to the function definition as well. That's one of the beautiful things, right? If you need to write a Fibonacci, you don't need to write it if. You can just do Fibonacci 0, 0, Fibonacci 1, 1, Fibonacci n is, n minus 1 minus 2. That's a very fast and elegant way to write if you have any kind of mathematical functions, for example. Does that answer the question? I think that was, I don't know who that was. Okay. Okay, let's see. Lib, super zoo, back to our super zoo. Great. Okay. Now we have, okay, so now we got the basic concept of a gen server. Do we have any missed black points on gen servers, guys? And ladies as well. Do we have any missed points on the gen servers?
I have a question.
Yes.
On the gen server, I know that I know that the Gene server is stateful, but I always see implementations of Gene server using some kind of a list, like you're doing on Handlecast. You are some way adding the state to a list that already exists, which is play. Is there another way of implementing a Handlecast without using that list, and the Gene server will be able to manage a different state from the current state? Like I'm having two different states in the same Gene server.
Oh, okay. I got the problem, but the solution is another way. For example, I had that problem in my product. So what I wanted to do is I have multiple concepts of a state. I have something like open files. I have something like open sockets. So what you can do is an elegant way of that would be is to use a map, and then implementing a key value inside it. That would be a very good way. And I think this is a map. Right, you could make a map, and inside the map you could have, for example, your sockets, right, and then you have a list of your sockets, and you could also have, for example, let's say FDs, right. You can have your file descriptors, right. So that would be a very basic way to do that, right. And inside here you can get your state, and when you want to do a change, you can say from my state's socket change this, from my state's FD change that. That would be a very easy way to implement that. Does that answer the question, Jaffer?
Yes, thank you.
Okay, great. Okay, now since that's out of the way, let's go to the next concept of using all of those, right? So we got to the naming, and for the naming, we also use this function, right? Where was it, right? Inside the start link, we could do, as we said, give it a name, which is a very basic idea of doing that. And now we can get to supervisors. Now, those are very, very important things when you are making a huge, larger scale software systems, right? Which is, by the way, one of the main ideas is with Go and Rust, you make software. With Erlang, you make a software system. So that's one of the beautiful things here. So what we have here is the concept of a supervision tree, right? So a supervision tree is basically a behavior. Just like Gene server is a behavior, a supervisor is also a behavior, which does only one thing. It monitors some other processes. It can launch and monitor some other processes, and when that process crashes, it will restart it up again, right? And you can make your own strategy. You can say like, okay, if my internal state, for example, if my internal state process dies, then restart that. And after that, restart my X type of Gene server, for example, my web server, right? So you can manage all of these kind of strategies, one-to-one, one-to-many, which after who, all of those are very configurable and very manageable. And using them are very simple, actually. So Elixir root directory files, when you make like mix new, you get an application tree concept, which looks almost like this. And inside that, what you can do is say, okay, I want to have a supervisor. I want to have a supervisor whose child is SuperZoo Petland, and the argument that I'm going to give is going to be Lua, right? Lua the cat. And I can give it also an ID, an internal ID, and I'm going to name it Lua the cat. And I also can have another application, right? Supervisor child spec. Again, who I want to have the zoo.petland, and I want to have Oberon, right? Oberon the dog. Great. Now we're having pets, all of them named after programming languages. So why not? So great. Now I have Lua the cat and Oberon the dog. Both of them are processes. They are running, and their supervisor is going to maintain them. Is going to monitor them. So if I start my application tree from ground up, which was here, right? Now it will start my applications. And it did that automatically, just because it was declaratively defined. So now without running anything, because it's already running in the background, I can do process.where is, and I want to see where Oberon is, right? And I can see that my lovely Oberon is, I think I did type something wrong, as always. Or I did not run it at all, actually. Great, I didn't save the file, and now it's running. Process.where is Oberon, and now Oberon is running automatically. And now I can also have my Lua, right? And Lua is running. So here's the beautiful part, because it's supervisor. If something crashes, I need to, the supervisor is going to start it back again, right? Because it's a complex system. You need to make sure that if something crashes, it will also get restarted. Great. So let's kill one of those guys. Let's say process.varies, process.exit, and I want to kill who? I want to kill Oberon, right? So process.varies who Oberon, right? That's my first argument. My second argument is going to be die. Die, Oberon, die. And now he's dead, right? And if I do a process where is Oberon again, now the pit number is different, now, right? It used to be 151, now it's 157, because the process has died and it started again in a fresh state, okay? This is the very basic concept of the supervision tree. It comes very handy. For example, in our product, we have a place where we work with multiple ZFS file systems, and one of them like monitors the file system, the other one writes stuff inside the file system, and sometimes some stuff get hanged, right? So and when something gets hanged, the operating system is going to like die in that callback, and my process is going to die. The OpenFD is going to die, and when the OpenFD dies, the supervisor checks that and says, "Hi, you died. You will start again doing your job." Right? So it's a very common thing and very useful, especially in web applications. When you have like multiple parts of your application, something dies, just to start again in the first state. So that's one of the concepts in Elixir, right? Let it crash. If in other programming languages it's try catch, in Elixir and Erlang it's let it crash. When your car stops, what do? You turn it off, you turn it on, right? If something is not working, we just turn it off and turn it on and wait for it to hopefully work back again. So this is a very basic concept of the supervisor tree, right? You can just define your supervisors. This is actually a very complex one because I added an ID. If you need, you can just do things like, my server dot my worker, right? And, for example, let's say my argument, and now you're done. That's it. That's all you need to have your supervisor running, right? So those are very basic concepts. Okay, questions regarding the supervisors. The supervisor was actually a very basic concept here. Let's discuss whatever we have learned until now so we can continue on the multi-tenancy and distribution. Any questions? You could talking about the dynamic supervisor. Yes, I actually don't know anything about the dynamic supervisors. They came around, I think, 1.7. 1.6, I never got into them, but they are very useful. What the concept is that you can run supervisors dynamically. And so let's say you have a chat room, right? Let's say you have a chat room, and each chat room is basically has a father supervisor. Someone is calling me, great. It's 4 a.m. Why is someone calling me? And right, so each chat room could have its own supervision tree, and now you can use your dynamic supervisors to load a supervisor for that specific chat room, which monitors all the client connections for that chat room, right? That's a very common way of doing it. Actually, I think even, what was that app's name? Discord, I think. There was a famous app, yeah, Discord. Discord yeah. has been using that for lately for their own stuff. I don't know much about it actually. Dynamic supervisors. I never even entered the page apparently for Elixir, but yeah, that exists. If anyone knows, actually, I would be very happy to learn about it more. That's a good question. Has anyone here ever used the supervision tree? From the people who ever wrote Erlang. Oh, and Elixir. Nice.
What is the question?
Has anyone here ever used the supervision tree in their project, or even dynamic supervision tree? Great. So we do have people who have done that. Great. Okay, amazing. Okay, do we have any questions until here again, other than the dynamic supervisors? No. Okay, perfect. Let's continue on. The next part is supposed to be the nodes, right, which is the fun part now. And let's start going there. I will now share my entire screen. Share. Great, perfect. Okay. Okay, so for this, I will need just need my terminal. Pretty much that's it. And let's come here. I think I can force this. Oh, yes, yes, thank you, bye-bye. Okay, great. Tmux. Tmux is the most amazing piece of software ever created. Okay, so what are we going to do? What are we going to do? We are going to run 2 nodes of an Erlang machine, of an Erlang VM, make them talk together, and then start doing whatever we learned until now, the naming process, for example, up to distributions. How do you turn something that has been built for a single machine onto multi-machines, and making sure that your code still understands that without changing too much stuff, which is very good, right? People these days talk about, you know, Dockers and microservices, and then they start changing their code and add what's called the gRPC from Google, and then they add some memcached and then Redis DB, and then, you know, and then this just goes on. Luckily, all of those are inside Erlang. So let's get to the basic one. So to run an Erlang node, what we need to do is we run Erlang node, obviously, and we can give it a name. Now, this is the important part. We can give it a name. Let's call this one foo at, I don't know, the very basic idea. And let's give it a cookie, right? The cookie is your authentication mechanism. And let's give it a cookie. Let's give it a cookie and name it Elug CE rocks. Great. And here we go. Now we have one running. Great, perfect, yay. And I run one more here. I say ix name bar at 127.0.0.1. And again, I can give it a cookie, which I cannot see. Great. I name it Elug CE rocks. Great. Okay, now I have 2 Erlang VMs running, and both of them have the distribution concept enabled. That's all I needed. So for managing nodes, we have the node module, right? I can see node.list. I can say node.list. I can see my 2 nodes. They don't know about each other. So the next process would be to use node.connect to connect the 2 nodes together. Of course, one of the most amazing parts of Elixir is the built-in documentation, right? Help.node.connect. It will tell you how to connect to it. Great. So I can do node.connect, and I will give it my other node name, which would be bar at 127.0.0.1, and here we go. True is done, right? I can do now node.list. I can see my bar. Here I can do node.list. I can see my foo. Now 2 of them can see each other, right? This is the very basic mechanism of connecting 2 nodes together. Okay. So now I can start even sending messages in between them, actually. So that's one of the most amazing parts, that I can also send messages in between them. So let's say I have myself in bar, right? I am process number 110. Amazing. I am process number 110, and I want to register myself, right? So we know already about process.register, but the process.register is only registered locally inside my own machine. But now I want to have a distributed naming mechanism. For that, we have something called global. Global is part of the Erlang system, is part of OTP, and it allows you to globally register names, right? So the first thing to do is actually global.start, I think, I'm not sure. Yep, I can do global.start. Now, well, already started, amazing. Okay, so error is already started. Thank you very much, global. Okay, now I can register stuff, right? Now I can do some kind of registration. For example, register name, register, where is it? Register name, right? And it takes two arguments. The first one is going to be the PID, I think, I'm not sure, by the way. And let's name it self. I want to register myself, and I want to name register myself as foo. Or it's going to complain and say, dear Antranig, you are not that smart. The arguments are going to be the other way around, which is one of the main reasons why my developers don't like Erlang, because everything is in opposite for some reason. Maybe it's kind of British, who knows? Okay, now I registered, and I got the answer is yes. Okay, so now I have a process named foo, right, which points to the PID number, well, 110, right? So now I can talk with this process from anywhere across the whole distribution. For example, here on my other node, I can say global.start, and I hope, okay, it's again started, thank you very much. And I can do global.whereisName, and I want to see foo. That's it. Now I get the foo's ID. Now, here's the interesting part. We already know about 110, obviously. But what we also can see here is this number, 12034, right? This is a relative number of the node bar, relative to the node foo. Now, if we do global.whereisName on another machine that's named Buzz, the 101 is going to be the same because it's unified locally, but the node ID, it might be different. However, both of them are going to look to the same thing, which is going to be the process number 110 with repeat 110 on the machine bar. And I can also use this, right? I can also say, for example, send. I want to send a message to, let's say, global.whereisName. I want to send the name to foo, and I want to say, hey, from node foo, for example, right? And I can send the message, and it's sent. Again, it printed back the message. And here, if I flush my memory, I can see that I got the message, right? Now I distributed my system and I made the name registration distributed instead of having it local. And if we want to integrate this inside the Gen server architecture, the Elixir documentation also has a very, very good idea of how that works. And if we go to the name documentation, you can see that what you can do is, instead of using name dot, whatever we used before, you can just say, I want to use a global and a term, right? So my pet name wouldn't be Lua. My pet name would be a tuple of global and Lua. Now it's going to be Lua everywhere, right? My Lua will be unique. My Lua will be everywhere, right? So that's actually, we can also do that right now. So that would be a very basic way to run that. Where is that? Let's forget about these supervision trees. Let's see, and comment these, for example, and let's go back to our super zoo, and the naming mechanism is going to change into global.petName, right? And great, right. Now that's it. Now this module has turned from a local registration into a global registration. The second part, right? Now I need to use it for my client. Great. Now we come here and we can say, instead of giving it the pet name, we can say global.whereisName. And that's it. Now my server and my function calls are being distributed across the whole node. Just by changing a couple of lines of code, I can get my system running from a single node into multi-node architecture. Okay, let's stop here and get some questions and go back. Any questions, guys? And I've seen some stuff. Blah, 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 yes, yes. And Kafka gives us headaches. Yes, everyone, well, not everyone. I forgot my beer in my freezer like you. I was drunk before even coming here. And I don't know what that means. So, okay. Any other questions that we have? Okay, perfect. Okay, so no questions.
Well, I got a question.
Yes.
You showed us a little bit about distributed nodes on different machines. And the question is, now I'm working into a local host server. So you are inserting all the data into your console and it's working. But when I have to create some kind of a release, Elixir release, using distillery or even Elixir releases, how would I manage to create this kind of list of distributed nodes if I'm working with dynamic IPs, from the Amazon servers and everything?
Yes, perfect question. Okay, let me boot up for you my work machine and show you an amazing example. This took us time, by the way, to figure it out. As in, people did not take the idea of let's call it a moving infrastructure. That's actually a concept of a moving infrastructure where nothing is static, everything moves around, into the concept of making releases in distillery, basically. And so what we did is we were able to manage to write some kind of a config file, an RC file, one would say, which is a basic shell environment variables, right? My foo equals bar, export bar equals buzz, etc., right? So that's how we started the whole idea. And what we ended up with is to show you a very basic concept of how we did it, which is actually very doable. Now I can easily just take a couple of lines of code here and there and make it running, connect to server. This is my, yes, NFS. Thank you very much. I can't believe I'm still using NFS, but you know, it works. So, and let me just share my screen because I did forget to share my screen. Let's say this terminal, share. Great. Can you see my terminal properly? Yes, yeah, good. Okay. Okay, perfect. Okay, so mount, where is it mounted at? Okay, great. So I need to go to volumes, Illyria. Great. And here I have one of my, this is my scheduler. I wrote my own scheduler. This is a scheduler for managing containers. And here you have your own distillery releases. Great. So what I did is I created a very basic example of an RC file, right? And what it has is it has an export of node name equals to whatever you want. Now this is changeable, right? You can change it to whatever you want, right? And it is going to be built part of the release. The second part would be to change the VM args into this. Now your name is going to be the variable node name, right? It's going to be the variable node name. Okay, now the first part is done, which is managing configuration. The second part would be, is to make sure that the distillery understands this, to run it, right? That's the complex part. Now, here is a very nice example in a config of a distillery. Wait, config.exs, great, right? And what I did here is, I made that a template, right? I made that a template that rel.illyria.rc example ex will be as illyria.rc.example. And what you need to also run, which is basically not that easy to do, is something called providers, a configuration file provider. Now, what the configuration file provider does is, before running the whole VM, the provider boots up, takes some variables, does the stuff, you know, read a file, check a socket, do this, do that, gets that, and then passes that to the real Erlang VM. It's think of it like an init RC system of your operating system, right? It boots before booting in order to make something happen. Now, my provider is actually like just a couple of lines of code, which is this. It's just, that's it. I tell it, you know, when you are running, just read the environment variable node name and then read the environment, you know, node cookie, and then I'm done. That's all I do, right? And one thing that you need to make sure is you have the concept of hooks. Very amazing idea. At pre-configure, I want to do what? I want to source my configuration file. So you source your configuration file. Now, all of those environmental variables are loaded into your machine. The provider makes the new configuration and then gives it to the next Erlang VM for it to boot. And now you can play with it however you want. So this is a very basic concept, just a couple of lines of code, and it just works fine. So again, we have the provider, we have the shell script, right, the RC file. I did it as Unixy as possible, actually. And then we have the pre-hook, the hook for pre-configuration, which is a very basic idea. It's not much, actually. Like if I run it right now, if I run the, you know, hooks pre-configure, right? Yeah, whoa, sh, for example, right? So this is what it does. Now it's complaining because it's saying Illyria RC file not found. It's just managing those inside each other. So if you want, I will be more than happy to make this as a gist for you and put it on GitHub so you can check. I have seen people who ask this question a lot on the forums, and no one actually found an elegant way to solve it. I'm not sure if this is elegant Elixir-wise, but it was elegant enough Unix-wise. You know, just one RC file, you put it in all your configurations, and you're done. And then you can manage it as the way that you want. Does that answer the question, William?
Yes, it does. perfectly.
Great, thanks. Okay, exit that. Okay, any other question, guys? Then we will move into, wait, we did the global naming, right? I think we did the global naming. And then let's have some theoretical talk about some other ways of doing distribution. Okay, so, okay, let me just get into that directly. So the next concept that we have, I didn't make a demo because it's already outdated. As of 1 week ago, it's outdated. So let me just share my screen very fast, and let's just give it my Firefox. Great, share. And here, so in Erlang, the other concept that we have for managing distributed processes and process registration is called PG2, right? It's called PG2. And let's do PG2, what's it called? Erlang documentation, great. So in PG2, the concept of PG2 is the same as global, but the difference is the global is a key value, right? The foo equals a process ID. Now the PG2 concept is that a foo, the key, the value is a list of processes. It's not just one process, they are a list of processes. So let's say you want to do some kind of a load balancing, and you always want to manage to give the process to the most close foo process that you have, right? And you can say, for example, where is it? You can say get members, and it will return to you a list of all the members of these processes. Or if you want to get local members, to get the ones who are the most closest to you, right? Or you can do get closest pit. It will return only one pit, but that one pit will be the one that is the closest to you for the sake of latency. Of course, currently it's actually just giving the locals, otherwise the remotes. But the reason why I'm saying this is outdated, because as of OTP 23, the PG, which is ironically PG is more modern than PG2, don't ask. And now PG is able to do more things. Now, it's the same concept, and it also has the same API. It's just that the implementation is different, and it's way better. So this is also one of the ways to do distribution when you want to do also some kind of a load balancing, right? Instead of having a global name value, you can have a name and multiple values, which are the list of processes. Okay, there's that. And there's also PG and PG2. I have no idea what's happening to my laptop. Okay, great. And that's it actually. I think pretty much that's most of the stuff that I wanted to cover. And let's see, this is the slide deck. Yeah, and also I want to talk key value storage and databases, but it would be way better if I can just prepare a video for that one day with a proper presentation, because Amnesia is really powerful. I've seen Amnesia at WhatsApp, and the things that you can do with Amnesia are just amazing. Like just doing a very basic introduction would be very lame and very shame. So one day I will show a deep dive inside Amnesia, and the Q&A. That's pretty much all, folks. You can all find me on Twitter. That's the only more mainstream place I exist, I think, and also my website. If you have any questions, want to contact me about Erlang, Elixir, or BSD, just text me any time of the day. Let me know that you're a friend from Elug CE, and I'll be very happy to answer any kind of questions. And yeah, questions. Any questions, Erlang related or otherwise?
I have one question. Actually,
yes.
Can you share with me your ix file? I can remember the full name. ix.xx file. Can you share with me? Because I saw
I don't have one.
Your output. Really? Are you using the full file?
Mine is the default. God. Yes.
Okay.
Why? What was different? I'm really wondering. My shell is different.
Because the output, your proper line, always keep on the screen, So your output always go to the next file, next line.
Yes. Yes, that is not, I don't know if it's an Elixir thing, but yes, it is also, wait, that's a very good question. I don't think that's an Elixir thing. I don't think that's an Elixir thing. In many systems, it would just, you know, do a buffer overload. It would just print it on your own buffer, which is very bad. I did that without using the Elixir configuration. Instead, what I do is I just don't use bash. That's actually a shell issue, the way that the shell handles the buffering. So I don't use bash. I hate bash. I've always hated bash. I hate anything GNU. I use pure shell. It's pure sh. It's just pure sh. And sh is able to handle the overloading of the buffers very, very good. If you're a Mac user, just go with ZSH, because ZSH does that out of the box, as far as I know. I know a lot of my Python friends use that specifically for that reason. Very good point, though. I just forgot, you know, the little things that makes you happy. Okay, any other questions? Okay, great. And no questions. Thank all of you for coming, well, technically staying here for the talk. If you have, and if something pops up in your mind and you want to know the solution of something, you know, regarding scalability or otherwise, let me know. If maybe during some time I will talk with Joel and do another presentation in a couple of months, but more advanced, more like a deep dive, debugging or concurrent programming and similar stuff. I think one person from my team is here. Martin is also here. Martin is our hacker, actually. He hacks stuff, so be careful. So yeah, there's that. So if you have any questions regarding Erlang Elixir, that project is on GitHub. Which project, bro? You mean the code that I wrote about the zoo? It would be very lame to put that on GitHub because I don't have anything on my GitHub. Well, that's not true. I do have some things on my GitHub. No, it's not, but I will share it. Absolutely. I will absolutely share it on my GitHub and send you guys the link. And so you can check the code and see what's happening. I will also put the gist for William. I will put the gist for the configuration files for the provider, and I think that would be useful. And maybe I'll just write a blog post and be done with that. There's also let's see. Okay, yeah, that's it. That's it.
So I have a question. Can you hear me?
Yes, Martin.
Yes. Will you post the recording somewhere? Where would you post it? I didn't listen. I didn't hear.
I think that's a question for Joel.
Hey, Martin.
Yes.
Yeah, we are recording, and I'm planning to post the video on our work in progress YouTube channel. It's not being announced yet, but as soon as we post it, we will announce it on our Twitter account. So I will just share the link so that you can follow us.
Okay, thank you. That will be great. There is like a lot of information in this. It's worth a rewatch.
Yeah, I'm posting the Twitter username so you can check our activities, and also feel free to join us on our Telegram channel. Actually, the Telegram group. I'm not sure if you are Brazilian or which language you are able to speak, but we generally interact in Portuguese over there. But we have no problems in receiving people from all the countries. So, Antranig,
okay, thank you.
You're welcome.
You were not. Oh, I'm so sorry.
No problem at all. Yeah, Antranig, you still there?
Yes, I am. It's actually almost 5 a.m. right now. Me and Martin are still not asleep, and we still have work to do. So, pro tip: never ever create a startup when you're young. Just do that when you have the money and have no other worries to do.
Yeah, man. Let me say this. Let me say this. I'm very grateful for having you on our event. It was such an amazing talk. You you went through a lot of things that were pretty much black boxes for us. We weren't able to understand most of the things that you touched before this talk, and it was great to see you showing the OTP platform in a more how can I put this in a more understandable way. Yeah, I know it's very, very, very late for you, so I just would like to thank you very, very much for being on our event. And I think, yeah, it's time for us to come to the end of this event. I'm very happy to have all of you until 10 p.m. now and 5 a.m. for Antranig. Dude, you're crazy. 5 a.m. So
well,
yeah,
I'm very happy to be here. If you guys have anything, I'm always happy to see anyone in the Elixir community. My next talk that will be how the compiler of COBOL works. If you have any questions regarding that, it's a very high-paying job, so especially during COVID times.
I would love to implement a COBOL compiler running distributed using all the cores and memory available into a distributed cluster of nodes. That would be amazing. I'm just joking. So, yeah, like I told you, we will be having a happy hour right now. And happy hour to drink some beer. I have mine here. Mine is like frozen, but it's still good to go. Yeah, I will be switching back to Brazilian Portuguese back again, so we can communicate in a more streamlined way. Again, Antranig and the Iluria team, very, very grateful for having you on our team. And feel free to ping me whenever you want, when you want to come back to us and share more of your experience with us. We are really glad to have you here.
Always welcome, guys. I'm more than honored. Anyway, it's late. Probably me and Martin have got to work, and I'll see you on Twitter. If you have anything, we will chat on Twitter. And if you have time, we also use Telegram. It's very common in Armenia as well. I'll also join the Telegram channel. I don't know shit. I love the language, but I don't understand anything. But I'm in all of these channels, so I'll be more than happy. Anyways, awesome. Thank you, Joel. Thank you for hosting. I'm very happy that you're doing this. I want you to go forward, and I'll also boost it to my Brazilian friends to join you as well, and see you guys grow. See you guys grow.
Bye bye, and
introduction. Thank you.
Bye bye, guys. Bye bye.
Okay, switching back into Brazilian Portuguese.